Who you like? Yeah. Okay. Well, thank you, Raja. Thank you, Nathan, for inviting me to give a presentation today. I realize many of you are probably dialed in from all parts of the world, so it might be midnight for some of you, it might be midday. So I really appreciate you guys taking the time here to hear me out. I'm learning as much as many of you are. And so in no way do I sort of claim that I've figured it out. I think every day that I meet customers and talk to people within the ecosystem, I realize more and more how much there is to learn, right? And so where I am today and what I'm presenting you today is a bit of my journey in this whole space, right? So this is the overview of the presentation, and I know there's so many words here, but I just really wanted to highlight a couple of things here, right? There's clearly growing business demand for real-time AI and machine learning driven applications. But clearly there's, operationalizing AI and ML is challenging, as many of you know. So in many ways, I feel like I'm preaching to the choir here. But what, my learning and my conversations have sort of guided me is there's a new data layer, a new data transformation challenge that many organizations are facing, right? And so when you actually look at these challenges and how to handle, real-time feature engineering, continuous training, being able to serve those models and monitor them, there's a lot of learning that we can do from customers and the ecosystem overall, right? So what I really wanted to do as I was trying to learn this space myself was establish first principles towards understanding this space, right? And so what I'm sharing here mostly in the presentation is a little bit of that first principles approach, defining what those pillars are using examples from the industry, and then also sharing a little bit about what we're doing at Redis Labs, right? And hopefully it'll be an engaging conversation, and then we can open up some time at the end for Q&A. So this is sort of the agenda. I really wanted to really look at the problem statement and why this emphasis on real time, right? A quick primer on first principles. Then I'll share 5 of the first principles that I'm sort of looking at when I consider real-time AI. We'll talk about Redis and then recommended reading and Q&A at the end. So a little bit about me, just so you have context for where I've come from. I spent a large part of my early days really in technical roles where I was software engineer, product manager. About 6 years I spent at Oracle, and I finally left Oracle doing business development role on the Oracle platform. That took me to AWS, where I spent a good chunk of time, about 10 years there, driving business development for AWS. When I joined, there were just 4 services that were externalized, and now there's, I can't even remember how many there are. There are probably about 150 plus services that comprise that platform. And so for about 10 years, I ran business development there at AWS. Great time really supporting a lot of the cloud scale customers, Netflix, Pinterest, Dropbox, Capital One, etc. That led me, interestingly enough, over the lake to Microsoft, where I spent 3 years building the customer success practice for Azure. And it's, they underwent a big field transformation back in 2017. And in 2018, they asked me to come in and really help out with not only building that capability, but then helping them with the cultural transformation that has really helped Microsoft over the past 6-7 years. But these days I'm at Redis Labs, and so I joined Redis Labs about 2 months ago, and I am leading emerging businesses for them with a specific focus on AI and machine learning. So that's just a little bit about me, and what I'm going to share here is largely a bit of my learnings. So clearly, when you look at a bit of the problem statement, there's clearly a growing demand for business demand for real-time apps, right? And that's underpinned in the fact that digital transformation is really going to witness 60% compound annual growth rate over the next few years, right? With over 50% of the use cases that are going to leverage AI and are going to need real-time inferencing capability, right? And, given the pandemic and the shift of many businesses going online, the digital surface area has increased, which means there's more data being generated And many of these companies, if they didn't have experience with digital technologies, let alone now they're just going to have an influx of data, right? And so the opportunity to help customers that are new in this game to really make sense of it's going to be really important. When you look at some stats, and this is from a number of different research reports, 89% of the AI adopters really want to perform real-time inference. 36% are saying storage is not fast enough, right? And this is storage sort of across the board. 30% say data locality actually prevents them from being able to do real-time inference, right? So you have data that's distributed, you have inferencing capability, maybe that you want to leverage in the cloud, maybe you want to leverage that on premise. And so there is this issue of data locality with the inferencing capability. This is a big market. I mean, $14 billion forecasted business opportunity over the next few years, right? So when you actually look at the problem statement, overall, nothing in fact to do with real time, just overall, operationalizing this stuff is really challenging, right? And I know I'm preaching to the choir. Many of you are probably knee deep in this challenge with customers or your own projects. Majority of the time is being spent building out architecture, so infrastructure capabilities underneath to get real-time support, but at the same time preparing data versus actually building models, right? And this has been gathered through different research reports. I wanted to reference here, a quote from Airbnb is they spend roughly 60% of their time on collecting and writing transformations just so that they can get it ready for machine learning tasks, right? And so that's really interesting. So with that problem statement in mind, there's this huge appetite for real time, right? And so I think the reality, and it's pretty straightforward and I think very, very intuitive, is that business is constantly evolving, right? Companies need to adapt very quickly to the growing rate at which change is happening, right? And when you look at the acceleration of digital businesses, it is resulting in more data from multiple channels, right? And so on one hand, there are business characteristics about real time, right, which are motivated through top line, bottom line, managing risk, etc. Time sensitivity, customer facing impact, responsiveness to ongoing introductions of regulation, right? So think GDPR, think CPAA, right? All these different things that are coming where businesses have to respond very, very quickly to those kinds of things, right? And obviously adherence to SLAs. But if you look at the flip side of it, though, that's where the technical requirements get really interesting, right? So because of the evolving nature of businesses and the need for faster response times, you need low latency access to processing, scalability, you need to have lots of requests and being able to process that. Versioning gets very, very important, right? Because what models you built today and maybe new features that are coming in real time are going to have require you to change them. And so versioning is very important because then you can actually see which models were effective based on which future data, right? Access control and API driven. There is a bit of an echo that I'm getting. Probably others are getting it too, so if you can go on mute, that'd be great. If we continue why real time, there are obviously a number of use cases that truly require real time because of this high degree of variability within that problem space, right? And so real time ensures that companies can be adaptable to those changes. And effectively, the more adaptable you are to the changing environment, the changing dynamics, the more resilient you can be, right? And if you actually look back exactly a year ago when the pandemic hit, companies that had infrastructural capability around digital transformation, AI capabilities, they were able to build resilience within their companies and their business models, largely because the analytical capability and the AI and machine learning that they built put them in a spot where they could learn very quickly and then adjust their models, adjust the way they did things, right? And so the reality is we typically build based on known variants, right? And so if you think of use cases where you can build models based on data that you already have with some level of variance as well too, and that's the beauty of what machine learning can do for you. sales forecasting, image classifications, predictive analytics, pricing. There's several other use cases. But now you have this interesting world where no matter how much you build a model, you are going to solve problems that are going to have high degrees of variance, right? And this is really where the variance is either really, really high or it's unknown. We can think about like fraud, cybersecurity. Given the fact that so many businesses are now going online and being digital, there's more opportunity for threats, right? And so, fraud cases have gone up across the board, right? And so many companies are not equipped to know what are those unknown fraud mechanics that bad actors are going to play with, even in cybersecurity. If you think about the different ways of email phishing, you can model based on what you know, but there's this percentage that is unknown, right? And so, given the variability, given the newness of what happens outside what you can build, you have to be able to very quickly learn from that, right? And even new usage patterns. I mean, I think with the pandemic, and this whole remote work, remote delivery, all those kinds of things really introduce newer buying patterns by consumers, right? Okay, so let's talk about first principles. I'm sure many of you are familiar with first principles because you have Aristotle on one hand of the spectrum that kind of coined the approach, right? And then you have Elon Musk, who's kind of now the megaphone for first principles, right? But when you break through that noise, what it all comes down to is looking at a problem and then boiling it down to the most fundamental truths, right? And then building up from there, right? Because what that allows you to do, it allows you to, build an approach and a hypothesis based on truths rather than analogy. Because analogy over time can drift from what is actually true, right? So I wanted to take you all through one example, a very simplistic example. It's probably not even, refined, but just for the sake of doing it. So there's this 5 whys approach, right, which many of you all are probably familiar with. If you take the example of operationalizing machine learning, right, natural statement is, hey, operationalizing ML and getting into production is difficult. Well, natural thing is, well, why? Well, too much time in engineering is spent in preparing data for training and serving. Okay, well, why is that the case? Well, data prep has many challenges. You have discovery of data, you have duplication of data because now you have like 4 or 5 different teams working on it. They're not sharing, so that's a challenge. And there's inconsistency with how features are defined. Well, why is that the case? Well, every team is managing their own sort of repository of features, resulting in inefficiencies. They're using their own tooling, they might not have the skill set. So there's a variety of different things there. Well, why is that the case? Well, there's no centralized system of record and process to bridge data, which are features, to ML models, right? And so when you go through this sort of first principle approach of asking why, until you can get to something very, very tangible and then say, okay, hey, now that I know kind of what the lowest unit is, or that single unit that I can start working with, let me go understand that and build up from there, right? So this is where I wanted to share sort of 5 principles, at least that I've been thinking about. And there's going to be expansion to this, and there's obviously going to be refinement of this, but this is where my head is right now. The first principle with all this whole effort, right, is you have to have a mission that transcends technology and focuses on business or societal value. To be able to say, hey, I'm just another AI company is probably not the way to go, right? The way to do it is you transcend the technology and then you really focus on things that give business, societal value, and longevity, right? And so I just wanted to share a couple of examples, and I'm sure there are many examples that probably you are familiar with, but I really like, these ones in particular. Grab Taxi, a global ride-hailing company in Southeast Asia. Even though at the end of the day, they're helping people get from one place to the other through the shared economy, driving system, their mission is to empower Southeast Asia through technology, right? And that's really, really exciting, right? And I love that, the child in the background also has the same excitement as I do. But if you look at the end of the day, Grab is doing fundamentally more than just transporting people, right? They're bringing technology for Southeast Asia. They're empowering them with the super app that they've built, right? Sonos help the world listen better, right? I mean, if you think about it, if you can help the world listen better, what that means is you improve the experience. You improve the experience, you can bring people around it. And if you actually see how their mission today is so simple, but how it creates second order effects of value, it's extremely exciting to see their mission, right? And then Microsoft, I mean, I think one of my favorite missions is empowering every person and every organization on the planet to achieve more. That is such a broad mission, which can take any form, any technology, right? And so I think it's very important whether you're with a company that has a mission or you're building a mission, you're an ML leader in a new group and you're coming up with what's the mission. You really have to understand why do you exist, right? And your existence has to be more than just we're an AI company or we're an AI team. Right? That goes to my second principle is once you understand the mission and why you exist and how you can actually make a difference in your space to the world, whatever it may be, you have to define your outcomes and articulate the characteristics of those outcomes, right? And so I really love the way Spotify did this back in, I think it was circa 2018, where they really started building their ML platform capabilities. They wanted to increase the speed of iteration for machine learning development by providing tooling that supports common development patterns. And so, based on that overall approach, they came up with these 4 very specific outcomes that they were trying to get to. Build a platform for active machine learning use cases, reduce cost to maintain them, democratize it, but then support state-of-the-art machine learning, right? And so when you have your mission and you start defining your outcomes based on that, what you can start seeing is it starts bringing a lot more clarity. And when you look at the third, and by the way, I'm highlighting this because it's going to build on my narrative for real time, right? Is building this platform capability for active use cases. The third principle is you need to go dive deeper into the scenarios that you're trying to build. And let the definition of those scenarios guide you for the requirements for the platform that you're going to build, right? I highly recommend reading Doordash's engineering blog posts on their overall journey in building this ML platform. And when you actually look at what they do as a business, right, they came up with 3 canonical machine learning scenarios. One, which were driven by online models, second, offline models, and then exploratory models, right? And so they said, hey, these are the scenarios that we're dealing with. So online models need to make predictions live in production. They're a critical path to the user experience, right? Just imagine you're trying to order something on Doordash because, you didn't have time to cook food. Your kids are screaming in the background for food, and you don't get the response time to put that order in, right? It's pretty critical. I have 3 boys. I know how it goes, right? Models and frameworks need to be performant and need to have low memory footprint for those ones, right? When you deal with offline models, you're predicting definitely in production, but they don't have that same sensitivity on latency requirements, right? And they might not be as critical in the user experience path. They're certainly orthogonal, but they're not critical in that. In that kind of scenario, runtime performance is secondary, right? Thirdly, they said, hey, we are dealing with such a dynamic environment that we need to learn how do we optimize, introduce new models, deprecate old models. So they needed effectively exploratory models to be able to build hypotheses, test them out, and then learn from that before they actually put them in production. Right? So with these scenarios in mind, they were able to then build on requirements for themselves, right? And so what I really want to have you kind of keep in mind is the online models, right? Because that's going to be very important in the real-time narrative that we're going to be talking about. To leverage Doordash again, once you have your scenarios defined, it can help you define requirements. And so as you define your requirements, make sure that they're foundational, but they're also open and have some flexibility in there, right? So there were three things that really stuck out in how Doordash has really approached this, right? Number one, they standardize on ML frameworks, right? There's so many ML frameworks out there. Some folks may have skills in one, some may have it in another, but they said, hey, standardizing on a minimal set of them at least ensures that we create some consistency, but we also give some flexibility for the skill sets that we have in our company. The second thing that they did is the model lifecycle. They said, hey, listen, we need to look at this model lifecycle end to end, right? Because we have training, we have offline evaluations, we have testing that we want to do, all those kinds of things. And so making sure that their requirements fit the lifecycle is extremely important. Thirdly, and a bit of the emphasis that I want to place here is around features, right? Because they identified that there are two kinds of features. There's request level features, right? Which is really kind of user experience based, actions that a consumer is doing, and how do you track those features? But then second, there are environmental features too about the environment, right? And so when you look at the environment, it is really about the underlying infrastructure underneath, right? So one's more of a kind of outbound feature management, one's an inbound feature management, if you want to be able to call it that way. So now you've defined your requirements, again, keeping them foundational, but yet keeping some level of flexibility, right? Because it is such a fluid space. All right. The fifth principle then is, if you kind of build up on that initial problem that we talked about, which was operationalizing machine learning is challenging because of the data. The fifth principle is making features first-class citizens, and by understanding the hierarchy of needs, right? And so this is a great post by Eugene Yang, who's an applied machine learning data scientist at Amazon. He came up with this really nice hierarchy of, when you look at the storage of features, how should you think about the hierarchy and what's most important, right? And we actually look at the bottom part of it, access, serving, and integrity. This has high relevance for real-time needs, right? Because in a real-time scenario, you need to have a fast online store. You need to be able to have fast online serving capability, and you need to have real-time monitoring so you can close the loop on that whole thing. And so the fifth principle here is just being very, very feature-first mindset, right, if you will. And I'm sure many of you are, but I think, given the fact where we are in this whole machine learning journey as an industry, this is one of the areas that's getting a lot of emphasis right now. And by the way, there's a lot of noise in the space too as well. Okay, so with those principles in mind, don't forget about the jobs to be done and the skills required to do that. And so this is a bit of a reminder, if you will, more than a principle, is know who you're empowering by what you're building and what skills they need to be able to be more effective. And so this was really nice, the Spotify team, because they have several hundred folks within their machine learning practice, and so it was very important for them to get the personas right and understand the breadth and depth of all the people involved, right? And so this really focuses then on the jobs to be done and the skill sets that are required to get those jobs done, right? And so looking at it through this, depth and breadth thing, who are you empowering? Back-end engineers, data scientists, research scientists, ML engineers, right? Or quote unquote, what I always like to say is, there's always a question mark of a new role type that gets created out of this, right? And so the latest thing that I saw the other day was you have product owners or product managers, but now they're calling this new persona an AI product manager, right? Which is more AI focused and AI driven, right? So don't forget about that. Okay, so those are the five first principles that I wanted to share. At least how it's framing my thinking, and wanted to share with the community here. Naturally, as you get into the specifics technically, right, and you look at the different components or the different pillars of the platform you're building, they're naturally first principles that you'll want to get right over there, right? But that's for a later time. All right. When you look at what the early pioneers have done, a large part of what we're learning right now has been influenced by these big companies trying to solve these problems on their own and creating solutions and approaches and thought leadership around it, right? So when you actually look at Intuit and Gojek and Uber, some of the work that they've done with the different projects, right? Gojek and Google partnered together, and out of that came this open source project called Feast, which is effectively an open source solution around feature store, right? Uber, they had the Michelangelo project, which is kind of an end-to-end machine learning platform. And out of that came the feature store. In fact, as history shows it, the feature store kind of coining came from Uber, although there can be debate about that. But irrespective, companies like Spotify, Pinterest, Netflix, right, the scale at which they reached, and if you look at like the amazing recommendation capability, I don't know if you guys use Netflix, I'm sure many of you do, Pinterest or Spotify, but it's just blazingly awesome. I mean, the recommendations I get on Spotify are just spot on, right? And so there's a lot that these pioneers have done. If you kind of look at some of the architecture around it, right? Doordash is one of those companies too. This is a little bit busy right now, but if you actually look at the real-time components in there around Kafka, event streaming, real-time feature aggregation, and then the actual online feature store, these are some of the real-time components that go in their overall kind of back-end machine learning architecture. I highly recommend, you have 20 minutes this week, definitely go read that blog post. It's very, very enlightening and educational. The second architecture I wanted to talk about was Spotify, right? And so Spotify, again, one of the early pioneers in the space. If you look at the real-time components with online feature service and then feature registry, and then online, the online store, and then the serving capability, those are some of the real-time components in there. It's definitely worth looking at these in more detail, right? Okay, so we established the business demand for real-time apps. Why real-time? We looked at first principles. In fact, we got a little bit of inspiration with some of these early pioneers of what they're doing, right? Let's talk about Redis Labs and sort of what we're doing here. So for those of you that don't know, Redis Labs is a company that's been around for 10 plus years. We are the custodians of the open source Redis database, which is a popular database for developers. At the same time, we identified so many operational value add features that can be implemented and leveraged by big enterprises, small, medium-sized companies. We created an enterprise commercial version of Redis, which we sell as Redis Enterprise. A little bit about us, and our popularity. We are one of the most launched databases on Docker Hub. In fact, give or take, we sort of average 5.4 million pull requests on a daily basis, right? And so very, very, very popular. Most used database on AWS. Stack Overflow had a ranking, and Redis came up on top. And there was a Datadog, survey done around top container images, and Redis came up top. So clearly, we're the most launched, most used, most loved. Very, very ubiquitous database, which I like to say powers the world economy. But I can be a little biased there. Real-time data, any scale, run on any cloud, right? And so 1 million databases created. We have 7,000 plus customers, 50% of the Fortune 10 and 30% of the Fortune 100, right? And so really exciting what the team has been able to do over the past several years. What do we use for it? Hey, listen, when people hear Redis, they think cache. And yes, that's where the early beginnings were as a company. But when you start storing a lot of data in cache, eventually you realize you can do a lot more things with it, right? And so over the years, the number of different use cases that have expanded from caching has been really, really exciting. So customers using Redis for session management, fraud mitigation, real-time data indexing, and all those kinds of things, right? And what that's allowed us to do is to go from being a cache where the value prop was and still is around sub-millisecond latency, right? 5 nines of uptime, good TCO and all that. And we have some, big customers in that space. Then going to being a real-time database, because then we added persistence capabilities, we added native data types around JSON, streams, time series. We said, hey, customers are using it for a variety of these use cases. Why don't we create native data types that just work well with memory so customers don't have to worry about that, right? And then finally, as we look at what we're doing and the path that we're going forward is we are now much more a real-time data platform than we are just a real-time database and a cache, right? And that's largely because of the programmable interfaces that we've created, the fact that now we have more AI capability, both powering real-time data models as well as AI serving. Right? I'll take a few minutes here and just kind of walk you through this, and then we'll open it up for questions here, and I think we'll be good on time. When you look at our enterprise architecture overall, I mean, it's quite busy here, but it shows you the different components, right? We have Redis core with what are those core infrastructural capabilities that we offer. They run on all 3 clouds, right? So your Microsoft, Amazon, Google, you can do all that. They're native data structures, if you look on the left-hand side, but then there are modules that we've created which sort of enhance the overall experience. If you wanted to use Bloom filters, time series data, AI, graph data, those modules support that. And then you can support the variety of use cases that you have up there. Now, in my journey with understanding what we can do with AI, I'm applying a first principles approach to this, right? And I basically said, okay, well, let me take it down to the most fundamental thing that Redis does. And if you look at it, it's all about speed. We are built for speed. We make things fast, right? When I looked at that and I said, okay, hey, you know what? We are built for speed. Let me understand the machine learning lifecycle to be able to really look and say, where can Redis offer customers value? And so, look, at the end of the day, I think you're going to find so many different ways for how companies, data scientists, thought leaders slice this whole ML lifecycle. What I've done here is just, make a canonical definition. Maybe I got it right, maybe I got it wrong. But for the sake of just establishing, an understanding, you have your data sources, you're going to prep that data. That's your classic data engineering work, right? But then you got to do feature engineering, right? Which is you're going to have a feature pipeline. You're going to go through a series of training your models, validating the model, and that's a cyclical loop until you as a data scientist are comfortable with what you're going to do. Then you'll deploy it, you'll serve it, you'll monitor it, and that'll help you with the retraining cycle, right? Very, very simplistic view. I've probably said stuff that maybe somebody agree or disagree with, but for the sake of argument, I established my first principles approach to this. Now I basically said, where does Redis fit today in the equation? And so what it is with Redis AI, we basically make Redis an inferencing engine. And what customers are doing today is they're actually using Redis to store feature data, online feature store, model store. And because they have both features and models stored in Redis, they can feature serve and they can model serve, right? And so when you look at that tight thing of actual feature data and then the models, this is where Redis is investing quite a bit of time with customers, because this is where customers are today, right? In particular, as you're looking to do real-time AI, the fast speed, the low latency, it all serves that well. But naturally, if you're going to do that, the other area that Redis is involved is an adjacent category of monitoring. And so as you put these models in production and you serve them, you want to learn from those online predictions to see, is there model drift, is there data drift, right? So we're putting some investments in how we integrate with, monitoring solutions like Grafana, Prometheus, but at the same time, being a little more thoughtful around the ecosystem around us that we can integrate with. If you kind of go a little bit back, another area that Redis gets involved in, less sort of on real time, but in model training, is in distributed training. If you can think about distributed training and multiple nodes that you're training, a model on, you have different parameter weights at each node, right? But the challenge with this thing is to get the performance of learning in a distributed way at a lower cost gets really challenging. Number one, because you're storing local data and maybe you're using file storage, right? What's nice about it is you can leverage Redis to basically get performance benefit and at the same time reduce your cost and overall training. And then, fourthly, another area that we see is data preparation. So if you look at classic, data engineering and data processing, Redis has connectors to things like, Spark and some of the other technologies out there. But being able to really help accelerate this at a lower cost is another area that we see Redis can really add value in the overall thing. But a large part of our emphasis is really on the right-hand side, which is online feature store and model and feature serving, and then the monitoring capability that you have around that. And so as we look at this and say, okay, in this whole ML lifecycle, which persona are we at the end of the day empowering? It's largely the ML engineer, right? And the data scientist as well too, right? But if you think about the scaffolding that needs to be required and the collaboration between the data scientist who needs to be knee deep in the models, the ML engineer is the one who are really empowering here to be able to help, construct these components, right? So, interestingly enough, the timing is great. If you all are excited about this, right, we have Redis Conf coming up here in a few weeks, right? And our theme for Redis Conf is to rediscover real time. And if you notice, there's the word Redis and rediscover, right? And so a bit of our theme with Redis is how, when you start using it, allows you to rediscover the different ways you could use it, right? And so it's a virtual event. I highly recommend you, if you can attend, that'd be great. I'll be giving a talk. There'll be several other partners of ours giving talks on how they're using machine learning, how they're using Redis for machine learning. So it should be a pretty exciting thing. I will end by saying, hey, I always like to recommend books that I'm reading, right? And so these are 4 of them that, I've either read or in the process of reading. Definitely great books to kind of ground yourself in. And there's some links there. In fact, my slide presentation references links to all the sources where I got my information from. And I'll work with Nathan and Raja to share that with you all. But here's my email address. Thank you so much for listening to my talk. I hope it was beneficial for you all. My email address is there, so I'd love for you to reach out anytime. Let's collaborate, let's brainstorm. I think it's the early innings of where we are in the space, and so I'm really excited to learn collectively with you and to kind of disrupt the space. So over to you, Nathan.
All right, thanks, Tamer. Does anybody have any questions? And we can use the raise your hand function to go ahead and then unmute yourself and ask the question, or you can ask your question in the chat, and we will make sure Tamer is able to answer. Nobody has any questions?
Either I was very clear and good in my delivery, or I was very boring.
I guess, yeah. Will slides and links to blog posts be available somewhere? Yes. So when we put the webinar up on our website and on our YouTube channel, we'll make sure to link to everything, to blog posts as well as the slides.
Great. No, that sounds good. Yeah, and if many of you have questions after the fact, feel free to reach out. Happy to take anything offline.
All right. So, question from Raj. In your experience, what size of businesses benefit from real-time AI?
That's a good question. I mean, I think it largely has to be less on size, but more on the problem space that they're trying to solve, right? And so with real time, I mean, look, not everything has to be real time, right? I mean, let's start off there, right? There are certain use cases and business problems where low latency is very much needed, right? And so that gets the real-time capability. I think what's important about not the fact that you're building to solve a real-time use case, it's when you think about solving something in real time, your design decisions and your architectural assumptions actually have to be very, very well thought out, right? Which means a real-time system could benefit you in a lesser real-time like scenario, right? In most cases, in some cases, maybe not, right? But to answer your question, I think it largely goes on the use case and the problem space, where real-time is more needed. At the same time, I do think that, I mean, there is a bit of infrastructural investment that you have to make in this space, right? And so when you look at the infrastructure investment, the skilling that's required around it, right, it does require some level of investment, right? So, very, very small companies that maybe don't have that technical acumen or that knowledge or that domain experience might not be able to benefit as much out of real time. And that's where I think, companies like us and then other ecosystem providers are trying to democratize it a bit, right? Just so that, the big companies like, Uber and Spotify aren't the only ones, that get to reap the benefits of what they've learned. That's why you see a lot of, startups in the space that have emerged as a result of the work that these big companies have done.
Great, thank you. Next question is from Kumar. How does Redis enhance the speed of data extraction?
Data extraction. So when you actually look at it, I mean, if you look at the primary use case of how Redis cache, improves read and write in front of a database, right? What we have seen some examples of where customers actually then integrate Redis within their overall data processing flow. And so they might have a Spark system, or they might not be using Spark, they might be using some other technology there, right? At the end of the day, it goes back to less on low latency, but then higher throughput that you can get, right? So you can get higher throughput, so the number of operations that you can actually pass through Redis significantly increases, right? And if you look at data extraction, I mean, we do have a Redis streams feature, right? And so if you think about sort of extraction in the streaming use case, similar to what like Kafka does with event streaming, we do have a module there that helps out with that, facilitates that data coming into Redis and out of Redis.
All right, thank you. And Sam actually raised his hand, so I'm going to let Sam go ahead and unmute yourself and ask your question.
Great. Well, I can imagine that the speed of the machine learning updates would cause more errors in prediction. Do you have any info on that?
Oh, Sam, could you repeat the question? I just got part of it.
Right. So my understanding is that as a function of the real-time dynamics, that you'd have faster updates to machine learning algorithms, and that as it's going through the training database, you'd have this overshoot and undershoot or errors in your prediction, just as a function of switching to real time. Do you have any info on that?
Yeah, there have been a few kind of benchmark studies that some customers have done. And I think there are two key takeaways, right? One takeaway is, depending on how you build your model and how you construct your feature store, you could effectively take real-time updates and update your feature store and then serve it back into the model so that you don't necessarily have to initiate a new retraining effort, right? That's ultimately, I think, where many are trying to go, right? So that you can at least not have to incur the expensive cost and time of going through retraining. But then the reality is this, is that, certain new data that comes through real-time updates may have no impact on your model because now your model needs to be retrained, right? And so this initiates what we're starting to see in some customers doing, is synchronizing the online store with the offline store, right? which is where then you would sort of initiate the retraining of the model, right? Now, I think it's still a little bit early, at least from my perspective. Probably a good thing for me to go dig deeper into is what are the trade-offs in that real-time update and the accuracy of the model, right? I think conceptually people sort of understand the different moving pieces here, but I still feel like we're still early days in really resolving the value that can bring, right? So, but I think there are a couple of benchmark studies that customers have done. If I can find them, I'll share them with you.
All right, thank you. Ayo, I sent you an answer to your question in the chat, so please take a look there. Jesse has a question. How common are real-time models?
How common are real-time models versus, kind of batch-oriented models? I would say what I've seen is, I've talked to several banks. We've talked to a number of these consumer-driven app type companies like, Doordash and some of the online delivery folks. Their problem space requires more of online or real-time models, right? Because they're right in the user experience, and then the latency requirements are just so important for those ones, right? Now, if you sort of ask them and say, hey, if you look at the universe of models, like what percentage are real-time versus that, I don't really know. It's probably worth figuring that out. But I would say it's so important to make sure that you have the first principles of the use case that you're trying to define and understanding what are the data latency requirements based on that.
All right, perfect. And I think we have time for one more question, and this one is actually coming from YouTube. So what is the most used ML ops framework?
That's a good question. I don't have a definitive answer there. What I will say is this, though. When you look at MLOps, it's in all these tools, right? They're very opinionated tools, right? And so it largely depends on where you are today in your maturity of AI machine learning and how opinionated you are with your approach, right? And so what I will say is that look at, hey, Kubeflow is leveraged quite a bit. H2AI has put quite a bit of emphasis around certain use cases that they're predominantly doing well. And you look at the cloud providers too, a lot of them are positioning end-to-end machine learning lifecycle or MLOps, right? So it's hard for me to say right now, like where the gravity is. So yeah, that's actually something that I would like to find out too.
All right, thanks, Tamer, and thanks everybody for coming today. That's all the time we have. This webinar is recorded, and it's going to be posted on our website as well as on our YouTube channel, and I'll make sure to send everybody an email who RSVP'd with the link. I'll work with Tamer on getting the links to his presentation as well as any blog posts he mentioned so that we can have access to that too. We do have another webinar coming up April 21st on coding up a linear regression algorithm from scratch. This is going to be a live tutorial, so if you have any Python skills or kind of want to watch someone work through a linear regression algorithm in Python, I would highly suggest joining. Thank you all for coming today again, and I hope you have a great rest of your days.